Hello, today we'll talk about cost of quality. Now, cost of quality is a metric that is focused on efficiency of software production, and it has a good correlation with productivity. Now, I know that some of you would have heard this metric and probably also wondered, does this have any relevance today? And is this an important metric? Now, I can tell you it is very much is, and we'll try to see how it is. Now, what really is cost of quality? Now, when you look at the cost of building a software, um, there is certain effort or cost that we spend in building quality into software, and that's one way of looking at cost of quality. So if you compare it with, for example, a car manufacturing plant, there would be a lot of wastage, and that wastage is primarily to ensure quality. Now, for example, there could be cars that get pulled out of at the end of the inspection line because they don't meet the quality standard, or uh, there could be cars that get rejected, due to reasons like poor engines, or the painting was not okay. Now, all of this is done because the cars that get finally shipped and those are available in the dealer are good quality cars, right? So these are steps essentially the manufacturer takes to ensure good quality, because nothing that gets into the customer should be of poor quality. So similarly in software, when the software finally gets into the business hands, it needs to have good quality, zero defects, so as to say. And what steps we take internally to make sure that this happens contribute to the cost of quality. So any software is, it's a series of steps, right? I mean, hopefully, right, we follow a series of steps. It doesn't really matter what model we use here. I mean, it's not a question of whether it's an SDL, I mean, it's a waterfall or agile or whatever, but there will be a series of steps. Now, some of those steps create the software. So these are those that add functionalities to the software, and some of the steps really reduces or removes defects in the software, right? So the question is, those are steps that add functionality. We should try to do more of those. And there are steps that reduces or removes defects. I mean, we should do that, but the question is, can you reduce that, or can we remove that? And we will be able to remove that probably when defects are really not there, right? So if you want to look at those steps in a little more detail, I mean, these would be the steps that really create the software, right? Gathering requirements, doing design, doing code, and all of these are adding value to the business, right? You're thinking about the new features that a customer wants. You're trying to see how best it will work, and then you're actually coding it to give that functionality to the business. So these are steps that add value. Whereas if you look at those that really remove or reduce defects, the test planning, the testing, the rework, training, root cause analysis. Now these don't add value to the business, right? These just make sure that the quality is good. But the question is, can these be reduced, or are these steps really needed? Now, to what extent this is needed, right? The only reason why testing is there is because defects are there. So the question is, should defects really be there? So those are the ones that we have to answer by looking at cost of quality. So in some sense, right, what we are essentially trying to say is that while we try to look at gathering requirements, doing design, and doing coding, obviously those have to be optimized anyway. That improves productivity for you. But at the same time, the ones on the right side that you see on the slide, the test planning, the testing, rework, training, and root cause analysis, are there because defects are there, and defects must not be there, or defects have to be minimal. And if defects are minimal, the ones on the right here would also be minimal, and that will give you a really good cost of quality. So when you look at the components of cost of quality, right? The test planning, the testing, and of course reviews is also there. I have not put that there. Now these can be grouped as appraisal cost. So appraisal is the defect detection cost, whatever effort we spend for finding defects in the software. The second component of cost of quality is the failure cost. Now that is the cost that is spent to correct defects in the software. So essentially the rework cost. And finally, the most important thing to remember is that defects have to be really minimized, which means it has to be prevented. So all the training that happens and the root cause analysis happens is to prevent defects in the software. So prevention is good, but then too much of effort being spent for that is also not good. And then hence prevention effort also has to be monitored. And there is some interesting statistics that says that a small increase in prevention cost really helps to reduce the appraisal and failure cost. I mean, it's just like the U curve. There is an optimal point at which the prevention, failure, and appraisal cost curves meet, so as to give you the most optimal cost of quality. Now, the metric holds good. And the metric is useful for us to look at, and when we compare with the benchmark, so that's where we will get inference of whether our COQ is good or bad, and what opportunities lies for us to improve. And some of the industry best numbers published, I mean, various organizations publish these numbers, McKinsey, the International Benchmarking Group, ISBSG, as well as internally also organizations have their own benchmarks. Now McKinsey published a benchmark which says that a good COQ, which is the best in class COQ, and best in class, remember, it's like the top 5 percentile, it's about 22%. I mean, that's a phenomenally low COQ, and that's distributed as appraisal is about 11%, failure is 6%, and prevention is 6%. Now again, this is the top 5 percentile. I mean, not many projects hit this number, but I mean, this should be like the aim. I mean, this is like the platinum standard in cost of quality. Now the average COQ is again around 28%, slightly higher than the best in class, but still a phenomenally good value, right? I mean, 28% COQ is still very, very good, and even today a lot of projects should aim for that. So what really this means is that if the cost of quality in a project is understood, and if when you measure it, if you find that a cost of quality is somewhere around 25 to 30%, then that's probably it's a very good value, and you are probably near the most optimal value. But if it is higher than this, let's say 40% or 50%, sometimes I've seen projects with 60% or 75% or 70% of COQ, then that really means that there is a lot of opportunities to reduce the waste and to improve the efficiency of software project. And if you're bringing down from, let's say, 50 to 30%, that's straight 10% improvement in your productivity, right? It's fairly a simple strategy to focus on making the software defect free, doing things right first time, and then that improves your cost of quality. It's also about people taking accountability for software. I mean, a lot of times we when we code the software, we think that, okay, hey, there is a testing stage that's going to come up later, or somebody else is going to do a review, and hence they will find the defects. And sometimes we are less careful in avoiding defects, but doing a few things right in the beginning, it could be as simple as following a checklist or having a good standard or a guideline to do the design, and so on and so forth. There are a lot of opportunities for us to make the software defect free first time, and that will improve the cost of quality. It is a very simple metric to measure because it's all effort based. So all that is needed is the effort that you spend for various tasks. If you have those, the cost of quality can be computed, unlike productivities and other metrics which needs many other stuff. And so by having a simple track of the tasks and activities in a project, you will be able to compute the cost of quality. It's a very great metric to look at internal efficiency, and a low COQ definitely means that the productivity is very high, or there is a high chance that productivity is really good, and you can correlate your internal efficiency with some of the best projects in the world, and then that's something you can be proud of if you really are able to get to a low COQ. So my final word is that please understand your project cost of quality to bring efficiency improvement. I think and if you know that what is your current COQ, it'll help you to drive a lot of efficiency improvements in your project, and that would finally benefit the customer as well as you, because your productivity improves as well as the overall quality of software improves.